So if I can prove this one's a right angle, and I already know it's a parallelogram, what do I know about all four of the angles? They're all right angles. So I only really need to prove one of them if we've already proven it's a parallelogram. We already have their slopes. What should be true about the slopes of two lines if they come together and they form a right angle? Slopes should be what? Not equal anymore. Opposite reciprocals. We've never said that earlier this year, have we? Opposite reciprocals. So we look at the slope of which two here? What two segments come together to form that angle right there? JM, LM. What's the slope of JM? 5/9. What's the slope of LM? Or ML? Let's turn it around since we already named it the other way. 5/-9. Looking at those two slopes, are they opposite reciprocals of each other? They're opposites of each other, but are they reciprocals? So not opposite reciprocals. So what's that tell us? Not a rectangle. Not a rectangle. I should probably write out reciprocal because somebody's going to get that confused with rectangle, aren't they? Reciprocal. Not opposite reciprocal, so it's not a rectangle. Do we just stop there then? No, now we check what? See if it's a rhombus. What makes the shape a rhombus? All the sides are congruent. Now again, going back to the fact we already know it's a what? Parallelogram. So if I know that this side is 5, what do I know about this side? It's 5. If I know this side is 8, what do I know about this side? It's 8. So really all I have to do is find two of the sides, and if these two consecutive sides are the same, what do I know about these other two sides? They're the same also. What can I do to find the length of each one of these sides? Distance formula. I'm going to try to do that right here. Pick me a side. MJ, JM. So I got MJ, and I'm going to use the distance formula. You're going to have to tell me this because I'm not going to look up here to find it. It's too hard to see. Distance formula looks like this every single time. If you want to plug it into your calculator, go right ahead. What are the x coordinates for the points M and J? Everybody make sure you're seeing that. Those are the x coordinates. I still got a lot of people putting an x and a y here and an x and a y here. So you're looking at the x coordinates. What are the y coordinates for M and J?
2 and 7.
Now I'm going to do a lot of this in my head. That's what it should look like. If you want to use your calculator, that's fine. If you want to work it out, I'm going to do it in my head. I know a minus a negative, that's going to turn to a plus there. Negative 11 plus 2 is negative 9. Negative 9 squared is, it's positive 81, right? Negative times a negative. 2 minus 7 is negative 5. Negative 5 squared is 25. Then I'm going to add those two, and I get, what, 106? Is that right? Now, you could take the square root of 106 on your calculator. We really don't need to, because all we care about is if this is the square root of 106, what's the next one that we find got to be? Square root of 106. All right? So we know this, the length of this one's square root of 106, 10 point something. All right? I don't have a calculator up here, so I'm not doing this extra math. Because all we really care about is that, are they the same? What other side am I going to pick? All right, JK. Now I don't want to pick which side. Which side do I not want to pick? LK, because what do I already know about these two sides? They're the same because it's a parallelogram. So I already know that. If I did that side, it better come out to 106. Otherwise, we messed up somewhere else. So for JK, tell me the x coordinates for JK.
-2, 7.
Y coordinates? 7 and 2. -2 minus 7 is -9. -9 squared is 81 again. 7 minus 2 is 5. 5 squared is, what's 81 plus 25? 106. So I now know that this side, where's it at? JK, that's this side. The length of that side is 106. What's that tell me about those two sides? They're congruent. Sides are congruent. So what's that tell me?
It's wrong.
If this side's congruent to that side, well, we know that these two sides have to be congruent. We know these two sides have to be congruent. So what do we know about all four sides? They're all congruent. So is a rhombus. What's the last shape we need to check? A square. Is it a square?
No.
Why not?
It's not right.
It wasn't a rectangle, so we don't even have to bother with that. So what are all the names that we could put on this one?
Is there any way it could be a rectangle and a rhombus?
If it's a rectangle and a rhombus, then it's a square.
Oh, that's what I meant.
The best name we would give this shape is a rhombus. So if they ask you for the best name, the most descriptive name, then we put rhombus. This case, on problem 56, they ask you for every possible name. So what are all the possible names? And again, going back to a trapezoid, if we lived in Pakistan, what other name would we stick in here? Trapezoid. Since we live in the U.S., we don't put trapezoid in there. But again, on the state test, I don't know. I don't know how to do that. Nobody ever bothered to explain that. Got to be able to do all that. Got to be able to explain things. I know this is a parallelogram because opposite sides are parallel. Show me slopes. Find that stuff. All right. I know this is a right angle because the slopes are opposite reciprocals. I know it's not a right angle because the slopes are not opposite reciprocals. So on, so on, so on. Find the lengths of them using the distance formula. If you don't know the distance formula and the midpoint formula by now, I got to control my R here because I want to say something smart like Maverick. And I'm not going to do it. Other questions? Today we're going to cover trapezoids and kites. Just write down that title. Trapezoids and kites. Last two four-sided figures that we're going to cover. We already know where a trapezoid goes on our little thing here, and we're going to write it down here in a few minutes also. Where do you think a kite goes?
It's wrong.
Under rhombus?
Yeah.
So like here?
Yeah. No, I feel like underneath the
Under off a trapezoid?
Yeah. Another one off quadrilateral, off a square.
We'll find out here in a few minutes, I guess. See if you can tell me before we get to the chart.
Can you at least tell us if any of us were right?
Somebody was right.
Really? I didn't say nothing.
Trapezoid, two different definitions of a trapezoid. Again, on this quiz, when I go to grade this quiz, I'm looking at the paper here, and I see Caleb's paper, and he's got quadrilateral, then he's got trapezoid, then he's got parallelogram. I'm going to know that that's acceptable. Because if a shape is a parallelogram, then could it have been a trapezoid? Yeah. Now, with the normal US stuff, or what it was 20 years ago, it shouldn't have been. But with things changing, so I'll know that. So if you decide you want to try to make things hard on Mr. Ebersol and you say, hey, I'm going to throw in trapezoid every time I get a chance, just to make him think about two different answers here. That's fine.
I'm just gonna do it so that like on the state test, I'll already be used to that idea.
Now, see, I say that, and I just don't know, because if it's graded and they're starting to do it now with a computer, so if they're grading it with a computer and they use, I'll try to find out, but if they use the US definition and they put in there using that form, then the computer's not gonna know, hey, it could be a trapezoid if we were in some other
Then I
country.
can just blame you, so.
Blame me anyway, that doesn't help your test score though, I don't care. Lots of people over the years have blamed me.
It's not your fault.
That's all right. I just give them one of these,
Not the sandwich?
get out of my face.
Sandwich.
What's the difference between these two definitions?
I thought you wanted this.
At least exactly.
So, the US definition, the definition I grew up with, says a quadrilateral with exactly one pair of parallel sides. So, it has to be its own branch out here. Alright? All other countries say quadrilateral with at least one pair of parallel sides. Well, that means that it could have what? More than one. It could have two pairs, right? So it would go in here. And then all parallelograms would be trapezoids. Now, does that mean all trapezoids are parallelograms? No. So either way that either one of those you use, I'll be able to figure it out. So on like that problem we just got done doing, could we have said it was a trapezoid? Yeah. Because it had at least one pair of parallel sides. Draw this trapezoid. What's these arrows tell us? Parallel. So those two sides are parallel. We're going to add a whole bunch of stuff to this. First thing we're going to add to it, the two parallel sides. Two sides that are parallel are called bases. So the two parallel sides are the bases. Parallel sides. Those are your bases. Don't get confused, because does a trapezoid always have to look like this one here? Is that a trapezoid? Yeah. Is this a base? No, the bases are the parallel sides. All right? So just because it's turned around, don't let that confuse you. Anybody have a guess? Forgot these were on there. The other two sides are called legs. Legs. What other kind of shape we covered this year that had legs? Triangles. An isosceles triangle, right? Now, in an isosceles triangle, what was true about the legs? Congruent, right? That doesn't always have to be the case for a trapezoid. Anybody have a guess what kind of trapezoid it is where the legs are congruent?
A triangle trapezoid.
Close.
A triangular
We'll get to that here in a minute.
You keep
The
turning.
base angles. The base angles are the angles that surround each base. So these two are a pair of base angles. Guess what D and C are?
Leg angles.
Another pair of base angles. So the base angles surround a base. There's two separate pairs of them. Used to be that I called them lower base angles and upper base angles. But then that confused Aiden because as soon as the shape gets turned like this, now they're on the sides instead of lower and upper, so I quit doing that. So you have two pairs of base angles. What do we know about all four angles in this trapezoid? What kind of shape is it again? It's a trapezoid. What else is it? It's a quadrilateral. So what do you know about all four angles in a quadrilateral? They always add up to 360. So all four angles always add to 360 degrees. You might want to put that down there somewhere. Don't forget, all these shapes, all four angles always add up to 360 degrees. Now Joe can say his name. What kind of angles would we call these then? Leg angles, maybe. That's not a good mathematical name. We don't use that name. But these two angles that surround the leg always got to add up to how much? 180. So they always add up to 180. The two angles that surround each leg add up to 180 degrees every single time. So this is one of the base angles from the top, one of the base angles from the bottom. Those two always have to add up to 180. The two angles that surround the leg always add up to 180. Now we should have already known this, because if I draw this, and I tell you that these two lines are parallel, we did this earlier this year, what can you tell me about those two angles right there? They add up to 180. They're the roommates. Same side, or not, consecutive interior angle, right? Again, I want to call them same side interior angle because that's what I always learn. But consecutive interior angle, so they have to add up to 180. Well, what if so we know that those two are parallel. What if I did this? What kind of shape do we have right there? A trapezoid. Those two angles, what's going to be true about these two angles? Add up to 180. Got to be supplementary. So that's one of the properties of a trapezoid. This angle, that angle always got to add up to 180. This angle always got to add up to 180. Now, does that mean that these two angles have to be the same? Not necessarily. Could they be the same? Yeah, maybe. An isosceles trapezoid. Not a triangle trapezoid, an isosceles trapezoid. Joe was using the wrong word out of the triangle name. In an isosceles trapezoid, guess what's true about the two legs? They're congruent, just like in an isosceles triangle. So the two legs are always congruent. Two legs are always congruent.
Just to do that, you want to spell that shape?
Yeah, probably. Doesn't have to be spectacular or anything. So these two sides are congruent. These two sides are always parallel. Part of the reason that I don't like using the world's definition for a trapezoid is because then you get the rules confused. for trapezoids and for parallelograms and all that stuff. If we keep them separate and say a trapezoid has to have exactly one pair of parallel sides, it's easier to keep all the stuff, all the properties separate. If it's an isosceles trapezoid, the next slide is going to tell us some properties of an isosceles trapezoid. Anybody have a guess what's true about that angle right there and that angle right there? They're congruent to each other. How about this angle and that angle? They're congruent to each other. So this pair of base angles are congruent. This pair of base angles are congruent. That's one of the properties of an isosceles trapezoid. Now, does that work for every trapezoid? No. If I drew this trapezoid, is that angle always congruent to that angle? Probably not. All right, so write these down. And this should say properties. This is a properties in an isosceles trapezoid. Properties in an isosceles trapezoid. Okay. So in an isosceles trapezoid, scare you, Abigail. Sorry. In an isosceles trapezoid, the base angles are always congruent. Oh, thank you. Don't be laughing at me. Think of it.
Wasn't me this time.
Base angles are always congruent to each other. So you got these two angles always have to be congruent. These two angles always have to be congruent. So if I told you this angle was 100 degrees, just something easy here, how many of those other angles in there could you find? All of them. If this one's 100, what's this one down here? 80, because they have to be supplementary. This one's 100, what's this one over here? 100, because those base angles in an isosceles trapezoid have to be congruent. If, this one's 100, what's this one down here? 80. The next thing, the diagonals. When you draw on a diagonal, remember that's going from from one corner to a non-consecutive corner. You draw on a diagonal. Guess what's true about the length from N to H and the length from S to T? They're the same. They're congruent to each other. Now, do these diagonals, like all these other shapes, and this is one of those properties that it bothers me because if you stick a trapezoid in there, everybody gets this confused. In a parallelogram, what did the diagonals do to each other? What did the diagonals directly do to each other? It bisected each other, right? For a parallelogram, rectangle, rhombus, square. Now they make a 90-degree angle for which of those two shapes? Rhombus and a square, so on and so on. There's all kinds of properties, but they bisect each other. Do these two diagonals bisect each other? So is this part up here equal to that part down there? They're not, are they? Now what Sam's thinking, and this confuses a lot of people, what's true about these two parts? They're the same. What's true about these two parts? So you might want to mark that on there. That part's congruent to that one. That part's congruent to that one. But does that mean that those are being bisected? Try to show Aiden up here a little better. So these are the diagonals, right? I'm going to show you how the diagonals in they look something like this. See how these two top parts look the same? And these two bottom parts look the same? If I connected those four corners, guess what kind of shape I'm going to have? Isosceles trapezoid. And then the last one, two sides are congruent. The two legs are congruent. So those are all the properties of an isosceles trapezoid. To prove something is an isosceles trapezoid. So if we know the shape is a trapezoid, ways to prove it, we could prove that the base angles are congruent. We could prove that the two diagonals are the same length. So if the diagonals in a trapezoid are the same length, then we know it's a isosceles trapezoid. Or we could prove that the two legs are the same length. Ways to prove a trapezoid is isosceles. So if we're on a graph like we just were on problem 56 there a few minutes ago, and we figured out it was a trapezoid, what might we do to figure out if it's isosceles or not? So if we're on a graph and we have this shape, maybe figure out the legs by using what? The distance formula. All right? Could we also draw in these diagonals and use the distance formula on those two to see if they're the same? Now sometimes, and you got to use your brain a little bit, if I have a trapezoid, see if I can draw this. Probably can't. If I have that trapezoid, I can't draw it. And that was one of my diagonals. If it was going vertically, could I find the length of it pretty easy?
Yeah.
Just by counting. And if this diagonal was going horizontally, which I can't see, I can't draw worth anything because that's not anywhere close to horizontal. But if it was going horizontally, I could just count. So use your brain and think, hey, well, I could do that, and that would be easier than actually using the distance formula. Does anybody think they know what a kite is?
Something good right here.
He wants to test today, doesn't he? We knew he was going to annoy me.
So they have like opposites of parallel sides, but they're not parallel to each other, only to each.
Close, you're using the wrong word in parallel. Two sets of congruent sides.
Yeah, that's what I meant, actually.
All right, two sets of congruent sides. All right. I forgot about this. We had a mid-segment. We had a mid-segment for a triangle. What was a mid-segment for a triangle? What did it connect? Two midpoints of the triangle. Guess what a mid-segment of a trapezoid does? Connects the two midpoints of the legs. So write all this. I'll give you a second to write that down. Mid-segment. We'll use this a lot, and this is probably, it's not very difficult. Mid-segment of a trapezoid connects the two midpoints of the two legs. The mid-segment's always parallel to the two bases, and it's always equal to the two bases added together divided by 2. We'll talk about that here in a second. So think back to the triangle, mid-segment of a triangle, and what you knew about the mid-segment of a triangle. It's just on that last test that the chapter 6 test that we took. The next two midpoints, think of the other stuff too.
It's like half of the.
Third side, right? So if I drew this triangle up here, I found the midpoint over here, found the midpoint here, I connected those two. If I told you that segment right there was 10, how long would this side and this triangle be? Does everybody remember that? So that would be 20. The mid segment was half as long as the third side. Well, that doesn't quite work out for a mid-segment of a trapezoid because it's got two sides that it's parallel to. So what you have to do with those two sides is add them together, then divide by 2, and that tells you the length of the mid-segment. So if I did this, if I told you this side up here was 12. This side down here was 20, let's say. How could we find the length of the mid-segment MS there? 20 plus 12, that's 32. Divide by 2, so that's got to be 16. You add these two, divide by 2. Handle that, Jeremiah? That's pretty easy, right? Now the bad thing, what if I had another trapezoid? Again, don't think just because I draw something that looks like an isosceles trapezoid, it's always got to be that. What if I had this trapezoid, and I told you this base up here was 12, this, the mid segment was 22. Could we find that third base?
22 divided by 2, no,
22
times 2,
times 2.
and then minus 12.
So, what you could do it algebraically, and I'm going to show you that here in a second. I would rather you just think it through out in your head. Like what Shelby and whoever else said anything just did. You take this mid-segment, you're working backwards, so instead of dividing by 2, what are we going to do to it? Multiply by 2. What's 22 times 2? 44. Then we want to do what? Do what with this 12? Subtract it off. What's 44 minus 12? 32. Then make sure that your answer makes sense. Does it make sense for that side down there to be 32 if that's 22 and that's 12? Yeah. What should always be true about the mid-segment? It should be in between the two bases, the lengths of the two bases, right? Now, if that confuses you, then could I set up this formula here? Forget the 32's there. We don't know it yet. How long is the mid-segment? 22 equals, how long is base 1? 12 plus, do we know base 2? So let's put a b in there. Could we solve that equation? Yeah. If you wanted to set it up algebraically, set it up algebraically that way. Maybe Devin doesn't like algebraically. He doesn't like the thinking it through way. Guess. Look at it and guess. I look at this, that's 12, that's 22. What do I know about this side down here?
It's 1 and 22.
It's probably going to be more than 22. So I guess I say, okay, let's try 40. Then I go back and I check it. What's 40 plus 12? 52. Divided by 2, 52 divided by 2 is 26. Is that what we got right there? So what do we know about this 40? It's too big. We need something lower. Guess and check. Figure it out. Use your brain. You have a question, Nate? If I get a question a second ago. Now kites. A kite looks like this. And this will answer your question where a kite goes on that chart up there. What all did we say? We said
I said, make a new one with all the trapezoids.
a new one off of trapezoid, a new one off of quadrilateral. So we'll call that 1, that 2. Somebody said 1 off of rhombus.
Let's say off the square.
We'll call that 3. 1 off of square, we'll call that 4.
B before parallelogram, or after parallelogram, before
After parallelogram, before rhombus. So here,
That's all we get.
that's 5.
Did any of those all right then?
Yeah, one of them's right.
Oh, ooh, I got it, I think. I got number 2. I got number 1.
This first one ought to tell you, well, no, I guess this first one doesn't completely tell you. Now it sort of does. So in a kite, you have 2 pairs of consecutive congruent sides. The definition that you'll see in a lot of dictionaries or something say 2 pairs of consecutive disjoint congruent sides. And all that means is if I take the congruent sides and I cut the kite, not in half because it wouldn't be half, but I cut the kite like right here, these 2 sides are congruent, these 2 sides are congruent. So I can cut it to where the congruent sides stay together. So those 2 are congruent, those 2 are congruent. What would happen if I cut it right there? What kind of shapes are formed? What kind of triangles? Isosceles. It looks like this one's isosceles, that one's isosceles, because 2 of the sides are for sure congruent, right? Now it could be equilateral, but we're not sure because we don't know that 30 seconds. So that's one of the properties. Anybody want to get rid of any of these?
Squared.
The one off of square, how come? What's it say right here?
But not all the sides are congruent.
All the sides can't be congruent.
Well,
So is it a square? Is it going to come off of square? No, so that won't work. Any of the rest of them that we could get rid of? One off a rhombus, why? All the sides can't be congruent, so it can't be a rhombus. So I can get rid of that one too.
Can't switch it. I like remember that.
Next one pair of opposite angles are congruent. One pair of opposite angles are congruent. Looking at this, name me a pair of opposite angles in my pictures that look like they're congruent. N and H. So that pair of angles are congruent. Only one, not the others, only one pair. One pair of opposite angles are congruent. Probably need to draw a better picture. That's not a very good drawing.
If we had another picture, would TN and HS be?
No, I don't know.
Well, we're gonna try not to turn us off if they're being school, they're not being
No, I drew it instead of.
That's not how kites look.
Instead of drawing using segments, I just took the pen on the PowerPoint and tried to draw it. It looks about right. I mean, it looks as good as if I drew it like this, freehand up here. Can we get rid of any of our numbers here? One pair of opposite angles are congruent. Off a trapezoid?
Maybe.
One pair of opposite angles are congruent.
Yeah, we only need one pair of.
Now in a trapezoid, opposite angles. Are opposite angles congruent in a trapezoid? That really doesn't have anything to do with the trapezoid, does it? What does it have to do with? No, I mean, what the opposite angles? The parallelogram. What do we know about opposite angles in a parallelogram? Opposite angles are congruent. Well, if this only has one pair, will it fit in here? No. So we can get rid of that one. Can't be under a parallelogram. Diagonals. If we draw the diagonals in here. What looks to be true about these angles right here? Where the diagonals meet? 90 degrees. The diagonals come together to form right angles. So when the diagonals come together, forms right angles. So we know each one of these is a right angle. All of them are right angles. I'm only going to put one box in there. Does that help us with anything? Now it makes it look like it might be a rhombus or a square again, right? Because the diagonals in a rhombus or a square formed right angles. But do these other things fit a rhombus or a square? No. Next thing, one diagonal bisects the other. One diagonal bisects the other. Which diagonal looks like it's being bisected? Remember, name a segment with two letters.
Segment NH.
Segment NH. So what's that tell me about segment NM and MH? They're congruent to each other. So those two are congruent. Now Joe looked at my circles funny. Does it matter what you use to show things are congruent? And part of the reason I put this on here is because we've been talking about the end of course test. They use some stuff that I never used in my life. So they might use something like instead of using a tick mark here, they might use like a squiggly line or something to show that those two are congruent. Who knows? I have no clue why. All right?
That looks like a face.
So make sure you just realize things are congruent when they're marked with the same thing. That's all that matters. How about this other diagonal? Is it being bisected? When I look at this, is this part the same as this part? No. These two parts are the same. These two aren't. So can it be any of these other shapes over here? No, because the diagonals in all those bisected both of them, right? So we know it can't be there. Last one here. Actually, there's one more after this. One diagonal bisects two angles. Which diagonal do you think is bisecting the two angles? We got diagonal NH and we got diagonal TS. Which one looks like it's bisecting both the angles? TS. This one here. So these two angles are congruent. Those two angles are congruent. So those top two angles there are congruent. The bottom two angles are congruent. Raven goes out with her mommy tonight and her mommy buys her a kite at Walmart so she can go out and fly it because it's going to be windy out today. That's where a kite came from. Not the other way around. There wasn't somebody flying a kite and then they made up the shape. The shape was there, all the properties of the shape were there, and then they formed a kite that you fly in the air off of that. All right, so when you build your kite, what should be true about these two angles down here? They should be congruent. What should be true about the length of this segment and this segment? Should be the same. The last thing, it is a four-sided figure. So what do we know about all the four angles in a kite? They all add up to 360. Yeah. Nah. I just covered it wrong. I'm too lazy to fix it.
I don't know, bro. I
I don't
wondered how it was
understand.
like that's supposed to be.
Yeah,
together.
that's understandable. I didn't jump all over you, did I?
Why you always got it?
Any suggestions yet? Two or one? One? Does it come off a trapezoid or is it its own thing? Its own thing? Its own thing.
You're wrong.
Kite doesn't fit any of the rest of them, all right? So a kite's just another kind of quadrilateral. It doesn't fit in with trapezoids, doesn't fit in with parallelograms, or any of these other shapes. It's its own. Just to save time. Then we check to see if it's a what? Parallelogram. We had 5 ways to prove something was a parallelogram. One of those ways said if both pairs of opposite sides are congruent. Do we have that?
Yes.
So is it a parallelogram?
Yes.
Are we done there? Do we just stop? No. What do we check next? See if it's a rectangle. To be a rectangle, what has to be true? Right angles. Now, if we know it's a parallelogram, do all four of these angles have to be right angles? They do, but do we have to know that?
No.
No. If we can show one of them's a right angle, we're going to know the other three are because it's a parallelogram and opposite angles are congruent and all that stuff. Do we know any of them's a right angle in this one? Next, what do we check? Rhombus.
Yes.
Is it a rhombus? How come? Because it has four congruent sides. Make sure on the test next week, that's what you're going to have to put. Why is it a rhombus? Because it has four congruent sides. All right? How about square? Do we need to check square? Three answers for that one. Next one, number 2. One of the ways, first, is it a quadrilateral? Second, we check, see if it's a parallelogram. One of the 5 ways that we talked about to prove something is a parallelogram is if a shape has one pair of sides congruent and that same pair of sides parallel. So is this a parallelogram? What do we check after that? Rectangle. Is it a rectangle? We don't know anything about the angles, do we? They didn't tell us anything. Then what do we check? Rhombus. Is it a rhombus? We don't know. We don't have enough information, do we? So where do we stop at? Now, if for some reason you wanted to stick trapezoid in as one of those, would this shape have been a trapezoid if we use the rest of the world's definition? Yes. How about this one? Yes. If you stuck that in, I'll take care of that. Next one. Is this a quadrilateral? Next thing we check is what? Parallelogram. Is it a parallelogram? No. What do we check after parallelogram if it's not a parallelogram? Rectangle. Do we go to rectangle? No, because if it's not a parallelogram, can it be a rectangle? So we don't even have to worry about that. So what's the only answer on this one? Quadrilateral. Next one. What's first name? Quadrilateral. Then we check what? Parallelogram. Is it a parallelogram? Give me a reason. 2 pairs of opposite sides are congruent, so we know it's a parallelogram. Then we check what? Rectangle. Is it a rectangle? It's got one right angle. Is that enough to say it's a rectangle? Yeah, if it's a parallelogram, because if that's a right angle, what do you know about this angle down here? It's a right angle. What do you know about consecutive angles in a parallelogram? They add up to 180. So if that one's 90, what's this one? 90. What's this one over here then? Does that have 4 right angles? So it is a rectangle. Do we stop there? Now you check what? See if it's a rhombus. Is this a rhombus?
Yes.
How come? Got 4 congruent sides. Rhombus. Do we stop there? What else do we know? Since it was a rectangle and a rhombus, we know it has to be a square. So how many answers on that one?
There could be 6. Maybe.
5
6.
on that one. Why 6?
Trap?
Could be a trapezoid also.
Yeah, so it could be 6.
Homework. Questions on the homework problems you want to see work? Which one? 56? On 56, Listen to what I'm telling you, because this is going to start our notes for today. I want you to write this down in your notes. So draw a little graph in your notes. We're going to do problem 56. You're going to have it right there in your notes. These are the kind of problems I like to put on test. Something where you have to explain this, especially when we get down this time of the year, because we got the end of course test coming up before too long, and these are the kind of problems that they would put on there. Things where you have to be able to explain what you're doing. Somebody help me out with 56 and tell me the letters and the coordinates of the points. Everybody has a book that they can open up and help me out?
Page 39.
So each of these shapes, they'd say to give the most specific name. You're going to be using that chart that we made, quadrilateral, parallelogram, so on, with kite and trapezoid stuck in there also. We're going to go down through and try to give the best name for each shape, the most specific. So that means the one that's the farthest down the chart. The first one, we look at this first one, we know that these two are here. We know that these two are right angles, and we know these two are congruent. Well, we know that all four angles of a quadrilateral always got to add up to be 360 degrees. If that's the case, these two are 90 each, so that's 180. Well, that leaves us with 180 for these last two. And we know that they're congruent. So we just take 180, divide by 2, we can find those angles. Each one's 90. So not only are these two over here a right angle, but these two are also right angles. So if we start looking down our chart, we know it's a quadrilateral, but that's not the best name, because opposite angles here are congruent. Both pairs of opposite angles are congruent, so it's a parallelogram. They want the most descriptive name, so we're just going down the chart. Then we check to see if it's a rectangle. To be a rectangle, it's got to be a parallelogram, and it's got to have a right angle in it. Well, this one does have a right angle, so parallelogram isn't the most descriptive name. We write in rectangle, that could be the most descriptive name, but we go on and we check. The next thing we check is to see if it's a rhombus. To be a rhombus, all the sides have to be congruent. Since we know it's a parallelogram, we'd only need two consecutive sides to be congruent, then we could say it's a rhombus. The bad thing is that we don't know that. So the best name that we can give this shape is a rectangle. We don't need to check trapezoid or kite because they're not as descriptive, they're not as specific as rectangle. So rectangle is a better name. Next one, this was on the quiz. You just took a picture just like this was on the quiz. You just took a few, start a class. We look at it. First thing we check, quadrilateral. Yes, it's a quadrilateral, but it's not, the best name's not going to be a quadrilateral. We check parallelogram. Opposite sides are congruent. Both pairs of opposite sides are congruent. So yes, it is a parallelogram. Is that the best name? We need to keep going down the chart. A rectangle. We know this is a right angle. If it's a parallelogram and it has one right angle, then it's going to be a rectangle because opposite angles have to be congruent. Consecutive angles have to add up to 180. So we know all four of those are right angles, so yes, it is a rectangle. Doesn't mean we stop there. We go on, check, see if it's a Rhombus. To be a rhombus, 4 congruent sides. Well, this has 4 congruent sides, so we know it's a rhombus. Well, if it's both a rhombus and a rectangle, then we're not going to call it either one of those. The most specific name is going to be a square. Again, we don't have to check kite, we don't have to check trapezoid because square is a better name. Next one, we first know it's a quadrilateral. If we know it's a quadrilateral, we can find this missing angle right here because the 4 angles of a quadrilateral have to add up to 360. 90 plus 90 is 180. 180 plus 120 is 300. We take 300, subtract that from 360, and we get this missing angle down here is 60 degrees. We check, see if, we already know it's quadrilateral, we check, see if it's a parallelogram. If it's a parallelogram, opposite angles have to be congruent. So it's not a parallelogram. We only need to write that down. It can't be a parallelogram. If it's not a parallelogram, then it can't be a rectangle, rhombus, or square, so we don't even have to check those. The other things we need to check, see if it's a trapezoid or see if it's a kite. To be a trapezoid, 2 of the sides have to be parallel. 2 of the sides have to be parallel. We look at this. We have that side and that side. For those to be parallel, these 2 angles would have to add up to 180. Well, they do. So we know it's a trapezoid. Now, with a trapezoid, sometimes it could be an isosceles trapezoid, and we could give it a better name, call it an isosceles trapezoid. But to be an isosceles trapezoid, if we go back and look at, give me a second to get back to it. If we look at, probably better off to do it this way. We look at the properties of an isosceles trapezoid. Each pair of base angles are congruent. So that's one of the properties. Base angles have to be congruent. Well, if I go back to this slide right here, and we look at these, if we know that these 2 sides are the we know these 2 sides are congruent, that and that are the base angles. Well, they're not congruent to each other. So the best name we can give it is just a trapezoid. We can't say it's an isosceles trapezoid. It wouldn't be an isosceles trapezoid. Next one, I look at this next shape. I know that's 120, that's 80. First thing I want to do is find these other 2 angles. I know that they're congruent to each other. 120 plus 80 is 200. I know that the 4 angles of a quadrilateral always got to add up to 360. So that leaves me with 160 degrees. Divide that by 2, that tells me this angle is 80. This angle is 80. We check through our stuff. We know let's get rid of that. We know it's a quadrilateral because it's got 4 sides. We check, see if it's a parallelogram. To be a parallelogram, both pairs of opposite angles have to be congruent. Well, these 2 are congruent, but these 2 are not. So it's not a parallelogram. If it's not a parallelogram, can't be a square, rectangle, rhombus, can't be any of those. But it could still be a trapezoid or a kite. To be a trapezoid, 2 of the sides have to be parallel. Well, it looks like those 2 sides, because this angle's 80, that angle's 80, looks like they're probably parallel. But also with that, to be a trapezoid, these 2 sides, or I'm sorry, these 2 angles have to add up to 180. They have to be supplementary to each other. Those 2 and those 2 have to be supplementary, and they're not. So we're not going to call it a trapezoid. We check a kite. To be a kite, if you look back at those things that make it a kite, it says it has one pair of opposite angles that are congruent, and the other pair are not. So this shape would be a kite. That would be the best name we could give it. We could get rid of quadrilateral there. On this next one, we graph this. We're trying to give it the best possible name. This is all that stuff that we did during class. You gotta be able to explain to me why that's the best possible name. So just give me a second. I'm going to graph it. -3, 3 is A. -3, 9. So -3 up 9, 3, 6, 9. That's B. 1, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's C. 1, 4. 1, 1, 2, 3, 4. That's D. If you graph it and you graph it correctly, you can probably get some idea of what it is and what it ain't, so you know what to check, so you don't have to go through all the headache. I look at this and I can probably tell right away, number one, it's a quadrilateral. So we know it's a quadrilateral because it's got 4 sides. Then we check parallelogram. Well, if I find the slope of this side and I find the slope of this side, they're not going to be the same because those two are not parallel to each other as long as I graphed it correctly. So we know it's not a parallelogram. So we don't even have to check rectangle, rhombus, square, any of those over there. The other thing it could be is a kite or a trapezoid. Just looking at it, it looks like it's a trapezoid. So let's try to figure out if it is a trapezoid. To be a trapezoid, 2 of the sides have to be parallel. Well, I look at these 2 sides. Remember, the parallel sides are called the bases. And I find the slopes of those 2 sides. The slope of this, since it's a vertical line, the slope of BA or AB is undefined. It doesn't have a slope because it's a vertical line or a vertical segment. The slope of CD, it's vertical also, so it's undefined. Well, if both of those are vertical, then that tells us that they are parallel to each other. So I'm going to write that down here. So are parallel, and if those 2 are parallel and the other 2 are not parallel, then that tells us that this shape is a trapezoid. So we know it's a trapezoid. Now, we want the best name. There's one name that might be better than just calling it a trapezoid, and that's if it's an isosceles trapezoid. If it's an isosceles trapezoid, then segment BC and segment AD should be equal in length. They should be congruent to each other. So I'm going to use the distance formula to try to figure that out. Let's do BC first. The x-coordinates for B and C are -3 and 1. So -3 minus 1. The y-coordinates for B and C are 9 and 8. And you can plug all that into your calculator. I'm just going to try to do some of it in my head. -3 minus 1 is -4. -4 squared is +16. Over here, 9 minus 8 is 1. 1 squared is 1. 16 plus 1 is 17. 17 is not going to come out even when we try to take the square root of it, so I'm just going to leave it that way. The length of segment BC is the square root of 17. All we really care about is AD the same length as that one. So segment AD, use the distance formula again. For A and D, the x-coordinates are -3 and 1. The y-coordinates are 3 and 4. -3 minus 1 is -4. -4 squared is 16. 3 minus 4 is -1. -1 squared is +1. Add those two together, you get 17. So the length of segment AD is 17. We look at those two. They're the same length. So that tells us, since those legs are the same length, those legs are congruent to each other. So that tells us not only is it a trapezoid, but it's an isosceles trapezoid. So the best possible name we can give that shape is an isosceles trapezoid. Again, if you were doing this on a test, you show me these slopes right here. Well, first you do the graph, that's a point. Show me the slopes. Tell me, since those slopes are the same, they're parallel, another 2 points. Show me the distance formula, find those two lengths. That's another point. Tell me that since they're the same, it's an isosceles, that's another point.